Sorry about that. I didn't mean to hit stop. I've got one more little part here. We are going to write the fourth degree Taylor polynomial. Okay, so the last one was third degree. This one's fourth degree, but we're not writing it for f this time. We're writing it for g. Notice that g is a composition of f. It's kind of interesting. G could be found by doing f of x squared plus 3, and it's centered around x equals 0 this time, which is really, really odd. When we've changed the center, instead of being at 3, now this polynomial is centered at 0. We're going to need to make an adjustment here. Okay, so here's kind of how this is going to work. I'll call this t. I want to write the fourth degree Taylor polynomial. So what I'd like, and this is for g, I want g of 0, because it's centered at 0, plus g prime of 0 times, and I'm going to write this in a minute here, okay? I've got to find a way to write this. This needs to be able to be at g of 0 here, or g of x, pardon me. But I want it centered at 0, which is kind of interesting. I'm going to leave this blank for a minute. We're going to come back to that. And then this would be g double prime of 0. And then again, I'm going to come back to this little polynomial expression here, but this will be the power of 2 over 2 factorial. Two more terms. This would be the third derivative of g evaluated at 0 times some expression cubed over 3 factorial. And then one more, because I want fourth degree, so this will be the fourth derivative of g evaluated at 0 times some expression to the fourth power over 4 factorial. Well, let's just start with those derivatives of g at 0. Remember, g of 0, or g of x, can be defined as f of x squared plus 3. So g of 0 is f of 3 if I substitute in a 0. Well, that's going to be handy because that's a value I know. In a similar fashion, g prime of 0 is f prime of 3, and so forth. So this is really, really nice. I can just substitute in. So g of 0 is really going to be using f of 3. G prime of 0 would be f prime of 3. I'm not quite done here with my polynomial. G double prime of 0 would be f double prime of 3. The third derivative of g evaluated at 0 would really be the third derivative of f evaluated at 0. And now you might be like, what? Wait a minute. I don't have a fourth derivative here. Well, darn it, but that may not be a problem. Because of this type of composition that f is, notice that g is defined as f of x squared plus 3. I already have this higher power of x. My fourth degree Taylor polynomial needs a power of x to the power 4. That doesn't mean I have to take it to the fourth power on the outside. It means my ending power of x is 4. Well, now here's what's going on here. Remember, my input has changed. My input is no longer x. My input is x squared plus 3. However, I want this centered at 0. I don't like that plus 3. I'm going to subtract 3 to get this centered back at 0. This is going to be x squared. And then this part right here, this would also be x squared plus 3. That's my new input. But to get this centered at 0, I need to take that 3 away. This would be x squared quantity squared. There's my degree 4. I actually don't need these other terms because this is going to result in a degree 4 power. So my Taylor polynomial, my fourth degree Taylor polynomial for g would be -4 plus 2x squared plus 7x to the fourth over 2 factorial. That's a little weird. This has got some technique to it that we'll be continuing to practice in further lessons. That's the end of our lesson.